This whole next chapter, the whole chapter, chapter 2, we are talking about variables. What are variables? How do we use them? All of that kind of stuff. Because this is really what makes algebra, algebra. Okay, we're going into pre-algebra, but in algebra we make general statements and we use letters that are variables. Yes?
Variables are like symbols used for numbers.
Yes. Variables are letters usually. They can also be other symbols. They are not usually used as other symbols unless you get very high up in math. So we usually just use letters. Variables are letters or symbols used to represent a number, number or numbers. Okay. Now, the word vary means that it can vary. The letter, if you put in something like this, if I was doing this pattern, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, notice what I'm doing. I'm multiplying by 3, but I'm changing this number. Okay, so the pattern really is that I'm doing 3 times a number. And so the number, the n there, represents that it can be different numbers. Okay, so when we're looking at variables, it's usually we're seeing a pattern. And in the pattern, we describe the pattern by doing 3 times n, because that's really what we did. We did 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. So the nth number, we don't know what it is. It's a 20th number. It would be 3 times 20. Okay? And so you're just using n as a representation, a generalization that I can put different numbers in there. N can be any kind of number we put in there. Yes?
So, like, if I wanted to write down, what would like the three's position be like in it? Like, I'm almost thinking, not necessarily I would call it like a base of the number.
It's not the base, it's actually the multiplication number that we're using, the multiple. Okay, it's 3 times n, so it's a multiple. Okay, multiplier. Okay. So when we're looking at these patterns, we like to check to see what we can look at. So they use some very interesting ones, I think. The grizzly bears. One grizzly bear has 42 teeth. So 2 grizzly bears has 2 times 42, right? Because if I have 1 times 42, 2 times 42, so this is 1 grizzly bear, 2 grizzly bears, 3 grizzly bears, 4 grizzly bears. I'm not going to write out what those answers are. I don't care about that right now. The pattern is, this is the number that's changing, right? So it would be, and I could use B as bears times 42. Okay. Now remember, we can multiply any way. So 42B is another way of looking at it. Branson, you have not moved yet. I asked you to do that quite a while ago. I'd like you to follow directions. So this again is describing the pattern. But what is the thing that's changing? It's the number of bears. Now we can write it as B times 42. That's the same thing as 42 times B. Again, we don't have to put the dot in between. Without the dot, it means times. Okay, so that's something to look at. Okay. So when we're talking about variables, we can use all kinds of letters. Okay, so most of the time we use American letters. The most generally used letters in algebra is what? What is the most famous used letter? Yes, Ezekiel. X. Okay, so X and Y are the two most common number or letters that we use to represent as variables. So X and Y are very common. But we actually technically can use any letter, and when we use any letter, a small letter is different than a capital letter. That's the interesting thing. When we're using variables, a small letter is different than a capital. Okay, we're gonna look at that more in a little bit in section 2 too. So that's some things about variables, but really it's just helping to describe a pattern. Okay, that's what we use variables for, because here we're just changing the number and it gives us different answers. Here I'm changing the number of bears I have, so the number of teeth I have altogether changes based on that. Okay, we're assuming none of the bears got teeth knocked out. They'll have a full set of 42. Come on, that was funny. No. Okay, so that is basically what you're looking at in 2-1. That's the whole thing for 2-1. Okay, we're just using variables to represent patterns. Variables are letters. I kind of gave you a hint on some of the letters. Okay. So, 2.2 is now we're taking words and we're going to write them into algebraic expressions.
This is for 2.2.
This is 2.2. So this is where we're going to look at some different things, but we're taking words. This is kind of, if we're doing something where we say it in words, how do I write that down in algebraic terms? That's really what it's saying. Changing to algebraic expressions. Okay, so we need to know what an algebraic expression is. An algebraic expression is any operation using at least one variable. Any combination of operations. I can't spell. Combination of operations using at least one variable. Okay, let's look at an expression. This is an algebraic That's what that is, okay? That's an algebraic expression. Do you see it's 3 times x plus 5? The operations are multiplication and addition. There's at least one variable in there. That's called an algebraic expression, okay? You could have x squared minus 7. Again, squaring an x is an operation. That means to multiply it by itself. Okay, then we subtract 7. That's an operation. Okay, so those are called algebraic expressions. The one thing I like to note when you're doing algebraic expressions, which you were doing in orders of operations, none of those had equal signs. If you remember them, they were like 3 plus 3 over 2 plus, I can't remember, 4 times 2 plus 16 over 12 plus 3. Okay, notice there is no equal sign in there. Okay, that's an expression. This is a numeric expression because it gives you all numbers. It's not algebraic because there's no variable in it. Okay, So this is not algebraic because there's no variable. But one thing to look at when you're talking about expressions, there's no equal sign. We might ask, can you simplify that down into one number? So sometimes we write equal signs because that equals that, but really what we're doing is we're just simplifying it down. That expression, we're taking those and doing the operations. So that doesn't really have an equal sign. Okay, we're going to talk about when we get equal signs later. Okay, so let's think about what kind of words would be used for addition, subtraction, multiplying, and dividing. Okay, those are my symbols for those. Okay. Think of when you're talking about an addition problem, what's one word you might say to indicate it's an addition problem? Yes?
Plus.
Plus. Of course, if I say 2 plus 3, we know that's adding, right? Okay, what's another word you might use for addition?
Add.
Add. You can actually use the word add. So addition is the same as add. Okay, anybody want to try to guess if they can figure out another one? Yes?
Addition.
Yeah, addition is actually the whole word. Usually we do it down by add, okay? We don't say the addition of 3 plus 2. Usually we say add 3 plus 2, or 3 and 2.
Find the sum of 3 plus.
Sum, the word sum of. Okay, the sum of is actually an addition problem because sum means the answer when I add two things together. Yes?
This one's kind of going out on a limb, but could you use the word combine? Like if you're combining the two numbers?
I think I could. I would take that. A combine doesn't necessarily plus, but I think most of the time it would be if I said combine. Okay. Does anybody think of anything else we might use?
Put together.
Yeah, that we could use. I could say put together. I'm going to say, if you say more than, this gets confusing. But if you're saying 2 more than 7, okay, then that is adding a number. If I add 2 more than. Or putting together was the other one, but that's too long, so I don't want to write it. Lazy. Okay, what are some words for subtractions? Yes?
Take away.
Take away. We have take away. That's one of the basic ones because that's why we learn about subtraction. You take those away and what are you left with? Okay, yes.
Remove.
Oh, I'll take remove. The synonym for take away, yes.
Minus.
Minus. The actual word is minus. So we use minus as a subtraction word. It's another one you can think of.
Did you say subtract? Or like,
Does anybody know what's the answer called in an addition problem?
the sum?
No, that's it.
Oh.
I said addition, didn't I?
Oh.
The answer in a division problem, what's it called?
Dividend.
That's actually in division.
Or there's 3 of them. There's the 1, 2, and then the bottom one.
What's the answer? Yes.
Subtract. Right now.
Yeah, it's an easier word than that. It's different. The difference of, okay? So it's the difference. Okay? It also could be less than. That gets really tricky though, because we write those problems wrong. Okay? So this is a special, the more than is fine, but the less than is tricky. Let's show you why. if I say 3 less than 10, how would I write that problem? 3 less than 10.
10 minus 3.
It would be 10 minus 3, because we want to have 3 less than this number, 10, so I would have to take 10 minus 3. This gets to be kind of tricky for people because we actually switch the order of the numbers. People like to just say, oh, I can go in and I see less than, I'll put a subtraction sign and we'll do 3 minus 10. No, less than actually switches it when we're talking about subtraction. Addition, it doesn't change it because it doesn't matter which way we order them when we add. It doesn't really make a difference. Okay, I'm gonna have to move over because I took up too much room. Okay, multiplication. What are some words for multiplication?
Multiply.
Multiply. We know that one. Lil, what's another one? What do you say when you're multiplying something?
Times.
Yes, times. Our most frequently used one is times. Okay, what's another one?
Did you say like to the power or?
Not yet, that's an exponent. To the power is an exponent. Okay, yes.
Did you say if it was like multiplied by 2 or 3, you could say double or triple?
Yes. So double is a special multiplication. That is times 2. Triple is a special multiplication. That's times 3.
And then there's quadruple.
Yeah, well, we could go on and on and on, but usually double and triple are pretty much the biggest ones we see. So yes, those are special cases. We're always multiplying by 2 if it's doubled. We're always multiplying by 3 if it's tripled. Okay. Anybody else? Does anybody know what the answer to a multiplication problem is called? Yes. Nope. Sum is still addition.
Oh, no, product.
The product of some numbers. Okay, that means to multiply. Okay. We're going to go to division. We're getting the most popular because not all the time are they very popular. So what? Yes.
Not dividend.
It's not dividend right now. No. For what? For the division?
The answer of division.
The dividend of? I don't think we use that one too often. Okay. Yes. What do we use for division?
Me?
Yeah.
Divide.
Divide. It's the simplest one. Divide. What's another one? It's more of a phrase. Yeah.
Well, whenever I think of I guess this is more of something I say to myself, but like, how many times does it go in?
Okay, that's
That's what I
a
always think.
reverse way of saying division. Okay, so you're just using the fact that division is the reverse of multiplication now. Okay, but yes, that is correct. Okay, what's another word we might say? How many groups of 3 can we get? That's divided. How many groups of 3? You're putting them into groups. That's what division all is about. It's dividing them into groups. Okay, so groups up. The other one, I'll guarantee you, nobody says this, but that is the answer to a division problem is the quotient. The quotient of, okay?
Oh wait, couldn't you just say quote?
Quote, no.
Oh no, that's
Yeah.
like the product, the
A
price.
quote is just something that we quote. We say the same thing. We quote somebody. Like you just said, can't we say quote? I'm quoting you because I repeated exactly what you said. Okay, so
Oh,
that's what a
so
quote
like-
is.
Mark my words, I quote that.
Yes, correct. Okay. So those are different words that use. Now, these are to help you when you're thinking about problems in real life and you say one of these, you are going to usually use plus, multiply, times. You might say double, triple. You probably won't say product of. I'm going to guarantee you, in real life, we probably don't use that one very much. I definitely tell you, you probably won't use the quotient of. But sum of, we might do that, okay? So there's different ways of converting words. Okay, so if I gave you this sentence, and for this, you are going to put in when I say something that changes. Okay. Oh, this is another one I didn't give. The total cost of 3 Snickers. Okay. Now, the total cost of 3 Snickers bars. Yes.
I was just gonna say, isn't it 2.3?
Is this 2.3? No, this is 2.2. This is the cost.
Are we still on 2.3?
Yeah, we're still on 2.2. Oh, those are addition problems. Oh no, there's division and multiplication. Okay. So the total cost, how do you find total cost? This is an interesting one. It doesn't go like we think it might. Yes.
Well, like, if you had the amount of one Snickers bar, then you would just add all the 3 up together.
Okay, so we could do it as an addition, because total kind of means addition. When we say total, so it could be the cost of 1 Snicker bar plus the second Snicker bar plus the third. I could call those S's. We don't know what it is. Okay, we know that the 1 Snicker bar costs a certain price. We'll call that S. The second one costs the same, so we'll call that another S. And we add those all up. Is there a different way of writing through S plus S plus S?
To shorten it, it's just since there's 3 S's, then you can just write S times 3.
Correct. Repeated addition of the same number is really multiplication. So when we have repeated addition of the same number, that's really what the definition of multiplication is. It's the number of times you're going to add F's. That's what multiplication really is. So that's a way of writing the cost in an algebraic expression. Because we don't know what the cost is, so we give S as the number of Snicker bars. Okay? This is how many, or this is the price of the Snicker bars. Okay, this is how many we have. I said 3, so we have 3. We don't know what their cost is, so we're going to call it S. That's an expression. That's an algebraic expression. Okay. The ones they give you as examples, I think, are craziness, but that's because I don't ever hear us saying these. Like the product of 4 and a number less 3. The product, so this is the product of, is it 3 and a number? Did I just say that? 4 and a number. 4 and a number, comma, less 3. Now I'll tell you that when you write that in a comma like that, that means you do the first part first and take a breath. Okay? The product of 4 and a number. That's what we want to do first. How would we write that? Then we're going to do the next part. So there's 2 parts to this because we have a product of and we have a less number there. Okay? What does product mean?
The answer when multiplying.
It's multiplying. Okay, so Peyton, what would it be? The product of 4 and a number, what are you gonna call it?
I know, I'm thinking.
I know I was looking at you, I don't know why. What are we multiplying together?
4 and 3, right?
4 and what?
Oh,
4 and a
number.
any number. Do we know what the number is?
It's less than 3.
No, it doesn't say that. It just says the product of 4 and a number. Take a breath, stop there. How would I write 4 times a number?
4 times 10.
Yes,
You would do 4 and then you do like a parentheses.
you could. 4, and what am I going to put next to it?
4 times 4.
And
And sure, we could do n, we could do x, we could do y, we could do a, we could do any variable. It doesn't give us the number. So that means it's going to be a variable. Okay? Yes.
Can you do a number symbol 4 times?
Don't have to. Remember, next to each other, it's an implied multiplication. That implies multiplication. Multiplication kind of goes away in math.
No, I mean like instead of putting an n there, you can put just the number symbol.
No, because we don't use number symbols. We use actually letters as variables. That's our most common use. Yes, 4x is the most common. You could put 4x here. Okay. Now we're not done. We found the product of 4 and a number. Then we have to do less 3. So what would that be? Yes.
Wait, doesn't the n go in parentheses?
Oh, I can. Does it make a difference? So question here. Is this and that different?
We have to do.
Okay, are any of those different? Yes,
Yes.
they're different. Which one's different?
Just the ones that have the parentheses and the one that don't, they are different. But the ones.
Do they mean different things?
The
Yes.
4n would be, say, if we know what n is, it'll be 4 times whatever n is. 4n, say we know n is like 3, then it's just gonna be 43. And then
Oh,
4,
whoa, 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 not in math.
it would be 4 plus 3.
Actually, these are all the same thing. These are 3 different ways to write multiplication. Okay, we drop our times sign because the times sign looks too much like an X. Okay, so then they replace it at the beginning with a dot to tell people, oh, it's really times. Okay, well then, oh no, let's show it by this. If I take 4 times the parenthesis of n, we're saying you need to write that as a different thing. So it's 4 groups of n. That's really what this means because this is a grouping symbol. So it's 4 groups of n, which is the same thing as multiplying. Okay. This is the mathematician's way of writing it because we get lazy. We don't want to write a dot and we don't want to write parentheses. So if it's a 4 with a letter next to it, you can just write the 2 next to each other and they mean 4 times n. Okay. New thing, new concept. We'll get used to that as we go. Okay. We've always used time signs or the dot, but now we're getting rid of all that and we're showing you what mathematicians shortened it to because they got tired of writing those things. Okay. Yes.
What's that symbol called again? The one they have like the big line kind of?
The big line.
The line right next to the 4 parentheses and 4 and 4 times n.
Oh, this is like a bracket of some sort.
Bracket.
Yeah.
No, I thought brackets like the
I don't know what the trick name
Square
is.
bracket.
It's a different type of bracket. How's that? Yes.
So it's 3 different ways. Goodness.
3 different ways
but they're all the same.
writing 4 times n. Okay, it's 3 different ways of writing 4 times n. All of those mean the same thing. They're just written differently. Kind of like 4.6, 4 3/5 and 23/5 are all the same thing, but they're written 3 different ways. This is 3 different ways to write multiplication now. We love to make it confusing, don't we? It's like synonyms. We use synonyms because we want variety in our words. I don't know, mathematicians just love to have different variety, I guess. Okay, so all those mean the same things. Okay, we haven't finished though. I'm going to just use, because right now I want to get you used to it, I'm going to use 4 times n. What does the next part say? It says less 3. What does that mean? Yes.
Does that mean like whatever it's getting times by is less than 3?
No. What would less mean? Yes.
-3.
Yeah, less means minus 3. We're just going to now minus 3. So after we multiply, because there's a comma there, we're going to multiply first and then do less 3. Okay? I will tell you, you will find very few people that ever say that in general language like that. And this is kind of a lesson in futility. It's getting you used to words that mean addition, subtraction, multiplication, and division. But it really has not a whole lot of practice in life. Okay? So, that's 2-2. Let's go ahead and take a break, and we'll come back and do the next part.